Howdy folks, how you doing today? We're going to be going through the first little bit here in R, our hands-on programming in R. Let me go grab that down here. So the first section here is just a quick little overview of what we're talking about. Most of what we're going to do is in Chapter 2, and then a little bit here in Chapter 3 as well we can start having some fun with. So if you've never programmed before, this will feel like a lot. If you've programmed before, it'll feel pretty similar. So again, not entirely sure where everyone is here. Hopefully once we go through and check out everyone's introductions, I'll have a better feel for where everyone is. But we don't need to get like super deep into the programming side of things. Really, what we're doing is learning to use R to do cool stuff with data. That's essentially what we're doing. So we're not going to hit some of these topics super deep, and that's okay. This is like a quick, let's get in and working here so we can start working with R code, and it'll be a lot of fun. All right, so let me go grab, I've got the course repository here. So this is a GitHub repository. I'm fond of GitHub here. It's a hosting provider of the Git source control tool. So all the R code that I do, I'll put in this public repository that you have access to. Later on when we talk about our lab exercise in the project, I'll show you how you can get a private repository that you'll have access to, and I'll have access to, but it doesn't need to be public to the internet. So all it really is a folder. So I made a project here, I already did that, sorry, in my GitHub repository. Now I'm going to make a new file in my project here. So let me do a new R script. Right, and now I can start doing something here. So the first little bit we're going to practice is some arithmetic, right? So if you remember your basic order of operations, please excuse my dear Aunt Sally, parentheses, exponents, multiplication and division, addition and subtraction. And I feel like we've done a bad job of this because I did have a college student tell me one time that you have to do multiplication before division because you say it first. And I was just a little bit confused by that because we all know, right, multiplication and division have the same level of precedence. We just do them left to right. So they had something like 5 divided by, let's do 6 divided by 2 times 3. And for some reason in their head, they thought they had to do 2 times 3 first, because it was multiplication, and then do 6 divided by 6. And I said, no, it's 6 divided by 2 is 3, times 3 is 9, and if we run it, R agrees with us, right? This is 9. If you want to multiply first, right, you add some parentheses. We're super happy with parentheses, right? We can force order of operations if we want here, and now we get 1, right? 6 divided by 6 is 1. So just remember, order of operations does matter here. And then some other interesting arithmetic, right? If we do... if you want to save values and use them as variables. We talked about that a little bit for our introduction lab. We could save these things as like name and major and things. We're going to come up with a variable here. So I'll just call this my answer, right? And then we use our fun little arrow here, the less than dash sign. And then we can say my answer is equal to, and I'll move that over here. And then when I run it, nothing really looks like it happens, but now I can see in values, answer has a value. So if I wanted to use that answer in later arithmetic, I can then do, okay, how about we say we want 5 times answer. And when we run 5 times answer, we get 5, because it's taking whatever value is stored in my variable here and using it in the arithmetic. So technically this is an object that we're working with. Once we start assigning these variables, these objects, we can store just about anything we want in here, which is really fun. So we can store values, numeric values, or we can store those strings, right, where I'm just giving it some text here that I can work with. So one of the cool things we can start doing is we can start keeping these things around and using them later. And why we like variables is it gives us some context. Right? The idea is I should know what this is here based on its name. Now, R doesn't care. This could just be the letter A, right? And it's more than happy to keep the letter A. Sorry, I gotta run everything here. There we go. Let me run all the lines, right? It can be the letter A. The letter A is not a very good variable name because I don't know what A means. Again, answer is not really the most interesting piece here, but that's okay. So if we wanted to do some sort of solving a problem or calculating something here. So if I wanted to figure out how much milk I need to buy, because I've got 7 kids at home and they all drink a lot of milk. I used to drink a lot of milk, but turns out dairy doesn't agree with me anymore. So we've cut down a little bit, but that's okay. So we might say this is, how about my gallons of milk needed. Now, if you have more than one word, I like this using underscores to separate it. This is one style. This is called snake casing, where we use these underscores to go in between. Other people like camel casing, we say gallons of milk needed. and they just capitalize every next word here. Whichever style you prefer. I like the snake casing a little bit better here. Gallons of milk. I think it makes it a little easier to follow here. Gallons of milk needed. And then we can say, okay, well, what is this? So that's going to be, well, I've got 7 kids, and actually Jasper doesn't drink milk because he's also a little bit intolerant there. So 6 kids, right? And they each drink probably 8 ounces a day. I guess if we count cereal, they're drinking more. But 8 ounces happens to be, right, 1 cup, and there are 16 cups in a gallon, right? So that's 1 divided by 16 or so. Right, so that's gallons of milk needed, and this will be like per day, right? Okay, and then I can take that, then I can say my gallons of milk needed per week. And notice as I'm typing here, it's suggesting these variables. This is super handy here. So when people say, hey, that's a really long variable name, it's going to be really obnoxious to type, you don't actually type it most of the time. As soon as it suggests it here, you can just hit tab. So like I did get a couple letters here, and it's like, oh, hey, do you want gallons of milk needed per day? I hit tab, and it will finish typing for me. And now I'm going to say per week. So that will equal then, right, we're going to assign it the value of my gallons of milk needed per day times 7. Right, that'll tell me how many gallons I need for the week. And then I can, we'll just say you should go buy this many, right? I don't even need to output it. I'll just see what the value is over here on the right. I got to run it all here, sorry. There we go. So about 2.6 gallons per week if 6 of my kids drink a cup a day, right? And that's not too bad, right? It used to be more, so it's okay. So again, just using some nice variable names here. R doesn't care. This could be, GMD, like for gallons of milk daily, and gallons of milk weekly. The problem with this is you're probably not going to remember what this means later on here, right? Because I'll remember it now for a minute, and when I come back to my code, or if someone else is looking at my code, they're going to have no idea what's happening here. And now you might hear from some people, there's this idea of adding a comment. You can put in something in your script that's not code. It's a comment about your code. So you could say, this is gallons of milk needed per day, right? And we could leave a comment here. So you use the pound sign. Now our author calls this the hashtag, and I would disagree with him. I don't think this is the hashtag, because what a hashtag is when you attach this pound sign to a word, and then you've got a tag you can use, right? This is the pound sign, or if you want to be even more technical, it's the octothorpe. But if you go around calling it an octothorpe, people will look at you like you're crazy. I sort of like that sometimes when people look at me like I'm crazy. So I'll go and do it just to be obnoxious sometimes. So forgive me. I'm going to call it the pound sign all the time because I'm old, and I really truly think a hashtag isn't until you attach it to a word. Right, because there's no tag here, it's just the symbol, it's just the pound sign. So anyway, so some people might say you could use comments here, and I would very strongly disagree and say, please don't ever leave a comment telling me what your variable means, just name the variable better, right? So instead of adding comments to tell me what you mean, so you only have to type GMD, just make it long because the computer's going to type it for you anyway. So I'm just going to undo all this stuff here because that was pretty awful here, and I'll leave a comment saying GMD equal, assign it 6 times 1 divided by 16, right? Terrible variable name here. And I'll just leave that there for you. Now I'm going to give that a save, and we'll call this my week 2 R file here. And I just want to show you here, now that I've saved it, I've got another file here, and in my GitHub desktop client, it says, hey, there's new stuff in this folder. We'll get a little bit more into Git, but basically, Git's job is to watch a folder for things to change, for files to change. Mainly source code files, code that we work on. And turns out code is written in English. It's pretty easy for us to see what it is, so we can see the contents of these things. My R-proj file has some interesting stuff here. We don't really care, just leave those alone here. But I really want the R file. So I can come back to RStudio and open my R-proj file, and it understands, hey, let's go open this file as well. And it's part of it, which is fun. So what we do with Git is it watches the folder for changes, and then we get to make these commits. A commit is like a snapshot. It says, at this point in time when I clicked the commit button, here's the state of every file in that folder, which is great. So we're going to build up a history of what has changed in here. Now, for this, green means it's new, and everything is new. Like we didn't have anything in here before. So we'll say this is week 2 milk example. And I'm going to say commit. Now, Git is a distributed source control tool. So GitHub is the hosting provider. They give us a cloud-based central repository or an origin that we can synchronize with. But synchronizing is a manual process because you generally don't want to automatically sync your code back and forth. Weird things can happen. So manually syncing means I need to push changes from my copy out to the cloud. Or if something in the cloud changed, I need to pull those changes down. Now, when we're working on stuff and it's just us, it's basically only pushing. We're making changes, pushing to the cloud, making changes, pushing to the cloud, making changes, pushing to the cloud. That's about all we're going to do with it. Not super interesting. Later on, we'll learn how we can collaborate with this, and then we can work with a team of people, which is much more interesting, and you could get much better work and higher quality stuff out of that when you collaborate with people. We'll learn it's a push and pull process, and we'll get into that later. But now what I can do, I can click this repository view on GitHub option here. It'll launch out the repository site. And then because this is made for looking at code, you can navigate the folder essentially as a website. So I see a week 2 folder here. I can click on the name of it and we'll open it. I can see the contents. I can go find that R file. I can see here's my R code. It's pretty exciting. So this is a great place for code because GitHub is made for code. Now what we're going to do is you're going to put your code out here, and then I'll be able to see your code and you'll be able to see your code. We don't have to upload files to D2L. You don't have to attach things. You don't have to email them to me when you have questions. You can put it in your GitHub repository, and then you can send me a link. You can say, hey, look, this line 3 here, and it gives me a nice little URL for line 3. Eric, I'm having trouble here. And you can send it to me and life is good. I can take a look and see what's going on and we can go from there. So it should be a lot of fun. I'll walk you through the next lab exercise we're going to do here, or at least the GitHub process. You'll do a little bit of some arithmetic here, just a little bit of practice solving some problems as we go here for that as well. So as I work on my file here now, as I go and change things, then I'm going to see different things will happen with my GitHub client. It'll say, hey, this file's changed. We need to go add some things here. So the other thing I need to look at is how much bread, I don't know, what loaves of bread needed per day. Now, this one's a little bit interesting because depending on what kind of bread you buy, you get a different number of slices. I'm fond of the multi-grain bread that has like the oats on top and it's got like nuts inside of it, and like little pieces of it. My kids hate it because they don't like all that stuff in it. They just like boring white bread, which is really sad. So we have to have 2 different kinds of bread. Now we could have a bunch of different variables if we want, but I'm just going to focus on the plain old white bread here. So loaves of, I'll just call it white bread needed per day, right? And that'll be, now Jasper doesn't eat the bread yet. He's only not quite 18 months old yet now, right? In a couple days, wow, a couple days he'll be 18 months old. So he's not eating bread yet, and again with his dairy intolerance allergy, we're running into issues there. But there's other long story about bread. So loaves of bread, we'll have 6 kids eating bread. Now they eat, so if they have a sandwich every day, that's 2 slices of bread every day. Lunch, we like sandwiches. Peanut butter and jelly is great. Meat and cheese, that's fine. Whatever you like here. Now, some loaves have 20 slices of bread there, but you have to subtract 2 because the kids don't want to eat the ends here for some reason. They don't eat the butts of the bread. Okay, so that'd be about 18 slices of bread in those white bread packages. Some of them have 12, right? Mostly the multigrain stuff comes with 12 slices, which is fine. So if we do like grilled cheese for lunch here, and each kid eats a grilled cheese, now I'm at 12 slices of bread, right? And I get 18 per package. Sure. And then again, same idea here. I'm going to say my loaves of white bread needed, I'm just going to change that to per week, is equal to, right, we're going to assign it a value of my loaves of bread needed. Now, if I don't like the first one, right, I don't want that first suggestion, I'm going to arrow with my arrow keys here. You can't see me clicking here. I'm just touching up and down here. Today, right, times 7. Right, and then I can see what that is here. So we'll calculate this. So I need about 4.6 loaves of bread a week here if the kids eat sandwiches every day. Now, it turns out they don't actually like eating it every single day, because they get bored of it eventually. I mean, when I was a kid, I ate peanut butter and jelly all the time, and I loved it. I still eat peanut butter and jelly sandwiches because I love it, and I'm just weird like that. But so we've got some nice variable names here. They're getting a little long. I should figure out how I can zoom this in for you because that's going to be a little bit small. I'll work on that for the next video here. Well, that's some quick basics, using some variables, doing some arithmetic. Again, our order of operations applies here, and then we'll look at some other cool stuff, and we'll talk about the lab exercise and some of the cool libraries and things we can import as well. All right, I'll see you in the next video, folks.